So like I said, we did that activity yesterday to lead into our new unit. It's all about exponential equations, which on a graph make a curve shape. Okay? It's written in the form y equals a times b to the x power. Okay? Remember, linear is y equals mx plus b. Quadratic is y equals x squared. Cubic is y equals x cubed. Exponential is y equals a times b to the x. Now, the most obvious reason that you could recognize this one as an exponential is because the exponent is your x. Okay, so if you ever look at an equation and the x is the exponent, that's exponential. Your x is the exponent. Now, the x represents time. The a is known as the starting value, or some people call it the initial value. And then the b is known as a factor. Now, you can have two different types of factors, a growth factor or decay factor. Okay, but the b is always your factor, and it's either a growth factor or a decay factor. Now, we're not going to for time purposes, but had we wanted to, we could have taken your graph and used those points to write an equation for your curve. But we're not going to do that because that would just take the rest of the class. Okay, now let's talk about how to know whether or not your b value is a growth or decay factor. If the b value, okay, so this number raised to the x, if this number is greater than 1, it's a growth. Okay, and a growth means that the curve would go up from left to right. If your b value, which is this number raised to the exponent, is between 0 and 1, so less than 1 but greater than 0, like 1/2, 1/3, 2/3, 3/8, anything smaller than 1 but greater than 0, then it's a decay. And that means your curve would go down from left to right. So every single one of you would have had what kind of graph from yesterday's activity? A decay, because all of you got faster the more times you did it, which caused the graph to decrease when it curved. Your b value will never be negative. Okay, it'll be greater than 1, or it'll be between 0 and 1. It'll never be a negative number. Okay, so let's look at number 1. For number 1's equation, we have y equals 4 times 0.2 to the x power. What is the a value? 4. So your starting value is 4. What is your b value? 0.2. So is this graph, before we even see it on the graph paper, is it going to be a growth or a decay? And why is that? Right, it's between 0 and 1, so it's a decay. That means it's going to go down from left to right. But to know exactly where to put it on here, we're going to create a table of values. So create a t-chart over here. And then I'm going to go ahead and give you x values. So just -2, -1, 0, 1, 2, 3, 4. Okay, once you've created a table with x and y's, fill in the x's with -2, -1, 0, 1, 2, 3, and 4. Huh? Yeah, I just picked random numbers. I mean, they're not totally random. I picked whole numbers, first of all, because they're easier to work with. I picked some negative so that I would see what's going on this side of the graph. I picked positive so that I would see what's going on this side. And I picked 0 because whatever point I plot right there is also my y-intercept. Yes. Yeah. Okay, now that we have x values given to us, how can you use those x values to find the missing y values in the chart? Plug them in our equation for the x place. So on the calculator, you would just type in the equation, 4 parenthesis 0.2 parenthesis raised to the, because it's an exponent, and your first x value is a -2. And when you type in a -2 in the x place, what do you get? 100. Okay, so to find the next y value, what are you going to plug in? A -1. So you can either retype it in, or you can just go up to it until it's highlighted and hit enter, and it copies and it pastes it, and then you can just cover up the 2 with a 1, whatever you think is easier. And so you get a y value of 20. Yes? Okay, we'll just get a different one and put it on my desk. I'll replace the batteries later. Okay, so now we're going to plug in a 0 for the x place to figure out what its y value will be. Make sure you delete out that negative sign first, and then cover up the number with a 0, and you get 4. So the next number we're going to put in the x is a 1. And so you get 0.8, and then you would plug in a 2, and you get 0.16, and then you plug in a 3, .032, and then you plug in a 4, correct, 0.0064. What do you notice? Oops, I forgot the second 0. Correct. The larger your x value gets, the smaller your y value gets. And as you continue to move right on the x-axis, it looks like every y value is getting closer and closer to what number? 0. See how it's like 0.8, then 0.16, then 0.02, then 0.0064. The further you go to the right, the closer and closer it will get to 0. It will never go below 0. It will just continue to get closer and closer. Like you couldn't plug in any number and it go below 0. Yeah. It'll turn into scientific notation eventually because it'll get so small. Okay, so now let's plot the ones that we can. We obviously cannot plot this one or really this one because -120 is going to be like way up here. Okay, you can just, kind of put a dot up there to show where it would be. 0, 4 would just be up 4. There's your y-intercept. 1.8. Isn't that right 1 and then almost up a whole unit, but not quite? So right 1 and then up almost to 1, but barely below it. And then 2.16 would be right 2. And then these numbers are so small that aren't they pretty much going to look like they're just sitting right on the x-axis? Okay, and they'll get closer and closer, and so we basically just have to sit them right on top of it. Now we can see that when you connect these points, it looks something like this, and it will continue to do that forever. Even though we didn't type in 5, 6, 7, 8, 9, 10, it will continue to go that way forever, and it will just get closer and closer to 0. And then on this side, it goes up forever. You can see it would have been -120, and then when you went out to it would have went up 100, so it just gets higher and higher on the left side. Now, there's a reason that it never goes below 0. Like, look, if I even plug in 4 times 0.2 to the 20th power, or not, yeah, to the 20th power. See how small it gets? It's scientific notation. It's so small. It will you could never get a negative number. Like it'll never say negative something. That's just scientific notation. Okay? So, and the reason that is because there's a barrier right here. Okay? And that barrier is called an asymptote. That was one of your words from the word search yesterday. Asymptote. And what an asymptote is, it's like an invisible boundary line that the curve approaches, but it never touches, and it will definitely never cross over it. It just approaches it forever and gets closer and closer to it. Now, on this test, they're also going, like your curve, your exponential curve will approach the asymptote forever, but it will never cross over it. It's like a barrier. Okay? On this test, they're going to also expect you to be able to write the equation of the asymptote. Well, isn't the asymptote line, that yellow line that I drew in, a line that cuts through the y-axis at 0? So that's the equation of it. Y equals 0 is our asymptote line. Any questions so far? Okay, number 2, there's not enough graphs, so we're not going to graph number 2. We're just going to talk about some of the parts of it. What is the A value for number 2? So that's its starting point. What's the B value? 1/2, or you can write it as 0.5, however you want. So this graph is also going to be a decay. Okay, because it's also a number between 0 and 1. So it's going to go down just like this one did, but it's not going to have a y-intercept of 4. Where do you think its y-intercept is going to be? 2. The A is the starting value, which is also your y-intercept for now. That can change later, but for now, our A value is our y-intercept. Okay, now let's look at number 3. What is the A value? What's the B value? So is this going to be a growth or a decay? Definitely a growth, because 4.2 is definitely greater than 1. Now, so we know by just hearing that it's a growth, that it's going to look like this. Okay, it's going to go up from left to right. So that means it will approach the asymptote on this side this time. But to figure out exactly where it is, we need to create a table. So x and y, I'm going to give you some different numbers this time, and you'll see why in a second. -4, -3, -2, -1, 0, 1, 2. Does anybody already have an idea of why I gave you more negative numbers? Because it's a growth, so over here is where it's going to approach the asymptote. Okay, and so over here is going to be the points that we weren't going to be able to plot anyway, so that's why I gave you less of the positive x values. So now plug those numbers in the equation for the x and figure out their y values. Shoot, I have no recording. Y equals A times B to the x power. So if that's the equation of an exponential function, I want you to tell me the A and the B value for this equation. Okay, look. Your B value is always raised to the exponent. So 2 has to be the B. Because if A were 0, 0 cancels out everything. 1. There's an understood 1 in the A place. Okay, so let's create a table. And we'll just use -2, -1, 0, 1, 2. Go ahead and plug in those numbers into the x place to figure out the y values. When you plugged in a -2, what was the y value? -1, 0, 1, and 2. Okay, so now let's plot these. -2.25 will be left 2 up a quarter. And the -1.5 will be -1, so left 1 up half a block. 0, 1, there's your y-intercept. And it makes sense that your y-intercept is 1 because your A value was 1. And then 1, 2 would be right 1 up 2. 2, 4 would be right 2 up 4. Okay, so you draw your curve. We have an asymptote at 0, because see how as I went to the left side, my numbers were getting smaller and smaller? Like had I typed in the -3, it would have been a number even smaller than 0.25. They get closer and closer to 0. And the equation of this particular asymptote line is y equals 0, because it cuts through the y-axis at 0. Now let's talk about domain, range, and end behavior. Okay, when you hear the word domain, what do you think about? X values, or the x-axis, which is left to right. So if you're walking along this exponential curve, this orange curve, how far could you walk left? Forever, right? Because as you could still, we could have plugged in a -3, a -4, a -5, and we would have gotten lower and lower on the y values, but we could have kept going left, correct? So you can go left forever. How far could you walk to the right? Positive infinity. As it's going up, aren't the points also moving out to the right as well? Now, on this particular test, they choose, this is called interval notation, they choose to use inequality. So this is how they'll write it. They'll write negative infinity to positive infinity, just like that, but they'll put an x in the middle for domain, and then they'll put that the graph is greater than negative infinity but less than positive infinity. So, I mean, as long as you got the right things, you should be able to pick the right one. Just know that if it's domain, you better pick an answer with x in the middle, because domain is x values. Okay, so range is all about y values, the y-axis, how far down we can go, how far up we can go. If you're on this exponential curve, how far down will it go? No, because there's an asymptote keeping it from going below 0. So it only goes down to 0. The asymptote won't let it go below it. And it goes up forever. Look, as on this side, it's going up forever. Nothing will keep it from going up forever. So in inequalities, it would be like this. 0 and infinity, but then a y in the middle because it's range, and then like that. Okay, so as long as you have the right things for left, right, down, and up, you should be able to pick the right thing on here. And it kind of makes it easy because if it's domain, it has to have x in the middle. If it's range, it has to have y in the middle. Okay, end behavior. On the test, it'll be written like this. Left, right. Okay, they'll give you the directions. And then they'll want to know what the y values are approaching. So on the left side of the curve, all the y values are what? They're approaching. Well, okay, look. Here's a y value of 1. Here's a y value of 0.5. Here's a y value of 0.25. The y values are getting closer and closer to what? 0 on the left side, the asymptote. The left side of this curve is approaching the asymptote, which is at 0. On the right side of the curve, all the y values are doing what? Going up forever, so infinity. We'll continue this lesson tomorrow, so there's no homework. You may switch out.